in a groundbreaking development that could reshape the landscape of Alzheimer's disease treatment. Researchers from Mass General Brigham and Washington University School of Medicine in St. Louis have discovered that xenon gas may offer a novel therapeutic approach to combating this devastating neurological condition. This innovative research, recently published in Science Translational Medicine, represents a significant departure from traditional treatment approaches and has already paved the way for human clinical trials scheduled to begin in early 2025. The research findings highlight a remarkable shift from conventional treatment strategies. While most current Alzheimer's treatments focus on targeting amyloid plaques and tau tangles that accumulate in the brain, this new approach leverages the unique properties of xenon gas to achieve therapeutic effects. The research team has demonstrated that xenon gas inhalation can effectively suppress neuroinflammation, minimize brain atrophy, and enhance protective neuronal states in mouse models of Alzheimer's disease. Dr. Oleg Butovsky, from the Ann Romney Center for Neurologic Diseases at Brigham and Women's Hospital, BWH, who served as senior and co-corresponding author of the study, emphasizes the revolutionary nature of this discovery. The ability of an inert gas to exhibit such powerful neuroprotective properties has opened new avenues in neurological research. One of the most significant advantages of this approach lies in xenon's ability to cross the blood-brain barrier, a crucial factor that has historically limited the effectiveness of many potential Alzheimer's treatments. The research gains additional significance from its comprehensive approach to testing. The team evaluated xenon's effects across different mouse models representing various aspects of Alzheimer's disease pathology. Dr. David M. Holtzman from Washington University School of Medicine in St. Louis, another senior and co-corresponding author, notes that xenon demonstrated protective effects in models showcasing both amyloid pathology and tau pathology, suggesting broad therapeutic potential. Understanding the mechanism behind xenon's effectiveness requires examining the complex relationship between brain inflammation and Alzheimer's disease progression. The research team's investigation centered on microglia, the brain's primary immune cells, which play a crucial role in maintaining neural health and responding to brain dysfunction. These cells act as the brain's first line of defense, constantly monitoring for signs of damage or disease and coordinating appropriate immune responses. The study revealed that xenon gas influences microglial activity in ways that could be beneficial for Alzheimer's patients. Previous research from Dr. Butovsky's laboratory had established methods for studying microglial responses to neurodegeneration, identifying specific phenotypes that could be modulated to provide protection against Alzheimer's disease. This new research builds on that foundation, demonstrating how xenon gas can effectively influence these cellular responses. Thank you for watching. If you found this video helpful or enjoyable, I'd really appreciate it if you could hit the like button and subscribe to the channel. It helps support our content and ensures you won't miss future videos. Thanks for being part of our community. The experimental results were particularly encouraging. When mouse models of Alzheimer's disease received xenon gas treatment, researchers observed multiple positive outcomes. Beyond the reduction in brain atrophy and neuroinflammation, the treated mice showed improved nest-building behaviors, suggesting potential benefits for daily living activities. Perhaps most significantly, the treatment appeared to enhance protective microglial responses associated with amyloid clearance and cognitive improvement. Xenon gas itself is not new to medical applications, having been used as an anesthetic and neuroprotectant in treating brain injuries. However, its application in Alzheimer's treatment represents an innovative use of this noble gas. The gas's ability to penetrate the blood-brain barrier efficiently makes it a particularly promising candidate for treating neurological conditions, as many potential treatments fail at this crucial hurdle. The upcoming clinical trial at Brigham and Women's Hospital marks an important step forward in translating these laboratory findings into potential treatments for human patients. The initial phase, focusing on healthy volunteers, will help establish safety parameters and optimal dosing protocols. This cautious, systematic approach to clinical testing reflects the researchers' commitment to ensuring both the safety and efficacy of the treatment before expanding trials to include Alzheimer's patients. While the clinical trials proceed, the research team plans to continue investigating the fundamental mechanisms through which xenon gas achieves its therapeutic effects. This parallel track of research could yield insights that extend beyond Alzheimer's treatment. The team has already identified potential applications for other neurological conditions, including multiple sclerosis, amyotrophic lateral sclerosis, and certain eye diseases characterized by neuronal loss. Practical considerations are also being addressed alongside the clinical research. The team is developing technologies to optimize xenon gas usage and exploring recycling possibilities, addressing both economic and environmental concerns associated with medical gas applications. These practical innovations could help make the treatment more accessible and sustainable if it proves successful in clinical trials. Dr. Howard Weiner, co-director of the Ann Romney Center for Neurologic Diseases at BWH and principal investigator for the upcoming clinical trial, expresses optimism about the broader implications of this research. The successful clinical application of xenon gas could open new therapeutic possibilities across a range of neurological conditions, potentially revolutionizing treatment approaches for multiple diseases characterized by neurodegeneration. The significance of this research extends beyond its immediate findings. Alzheimer's disease remains one of the most challenging neurological conditions to treat, with its complex pathology and devastating impact on patients and families. Current treatments offer limited effectiveness, and the disease's progressive nature continues to pose significant challenges for healthcare providers and researchers alike. The discovery of xenon's potential therapeutic effects represents a novel approach that could complement or perhaps eventually replace existing treatment strategies. The timing of this breakthrough is particularly relevant given the growing global burden of Alzheimer's disease. As populations age worldwide, the number of individuals affected by neurodegenerative conditions continues to rise, creating an urgent need for more effective treatments. The relatively simple nature of xenon gas administration, combined with its ability to cross the blood-brain barrier, could make it a practical treatment option if clinical trials demonstrate its effectiveness in humans. This research also highlights the importance of exploring unconventional approaches in medical research. While much of Alzheimer's research has focused on targeting specific protein accumulations in the brain, this study demonstrates the potential value of addressing the condition through different mechanisms. The success of this approach could encourage more diverse research strategies in treating other neurological conditions. As the research community awaits the results of the upcoming clinical trials, this study serves as a reminder of the continuing potential for breakthrough discoveries in medical science. The use of a simple noble gas to treat one of medicine's most complex challenges demonstrates that innovative solutions can emerge from unexpected sources, offering hope to millions affected by neurodegenerative diseases. Thanks so much for watching. If you enjoyed this video and found it helpful, we'd really appreciate it if you could give it a thumbs up. It really helps support the channel. And if you'd like to see more content like this, don't forget to hit that subscribe button and turn on notifications so you never miss out. Your support means the world to us. Consider clicking on the videos linked in the corners if you want to watch more.